Assalamualaikum everyone. In this video, we will be presenting the operation in the fertilizing industry, focusing on the industrial hazard and the countermeasure that can be applied to ensure a safe and healthy working environment for the workers. We hope this presentation provides useful insight and we kindly ask for your full attention. Thank you. Abstract. The global fertilizer industry is crucial for food security, converting raw materials into essential nutrients like nitrogen, phosphorus, and potassium. However, this process involves significant hazard, including extremely high pressure and temperature, and the handling of highly corrosive and caustic material like sulfuric acid, which seriously challenge process control, instrumentation, and safety. To mitigate this risk and ensure operational reliability and sustainability, the necessary corrective action involves specifying innovative, high-performance instrumentation and implementing precise process control as supported by chemical process safety data. Now, let's get into the introduction. The fertilizer industry is the fundamental to modern agriculture and crucial for global food security, providing the three essential macronutrients required to boost crop yield. The necessity is amplified by the need to feed an estimated 10.9 billion global population by the century end, and by the growing demand for the biofuels derived from crops. Now, let me explain about the three main fertilizers, which also known as NPK. First, we have the nitrate fertilizer, where the foundation is the Haber-Bosch process, which synthesizes ammonia by reacting nitrogen source from the air and hydrogen, typically sourced from the natural gas. The product is produced then used to create essential products like nitric acid, ammonium nitrate, and urea. And Haber-Bosch process is extremely energy intensive and require extremely high pressure, precise temperature control to function efficiently. Second, we have the phosphate fertilizer, where the main process is the wet process. This involves the chemically treating the mined phosphate rock with sulfuric acid. Then the direct product of the wet process is the phosphoric acid, which is used to make final phosphate fertilizer like triple superphosphate (TSP) and diammonium phosphate (DAP). But this process can cause the worker to be exposed to a highly corrosive and concentrated acid, which is sulfuric acid. And lastly, we have the potassium fertilizer, which is the primarily made by physical method. This involves the mining of potash rock, followed by treatment and concentration using techniques like flotation or crystallization to separate the potassium salts from the impurities. The dominant product is the potassium chloride, also known as muriate of potash (MOP), the most common form of potash fertilizer. The main challenge related to the mining operation and the recovery required to separate the purities and desired potassium compounds from the raw mined ore. The significance of our finding can be attributed to four key beneficiary groups. First, for the industry, our research highlights the need for high specification instrumentation to boost plant viability, minimize downtime, and ultimately increase profitability. Second, the study strongly emphasized worker well-being. It is established that accurate monitoring and control are essential to create a safer work environment. This is vital for minimizing catastrophe, failure, or exposure to hazardous material such as strong acid and high temperature steam. Third, the findings are critical for the government and regulator. We provide an evidence based on high-risk chemical environments to strengthen specific safety guidelines. This is especially relevant for environments characterized by extremely pressure and corrosive media. Finally, In terms of contribution to the body of knowledge, this research expands the practical understanding of process instrumentation, informally denies it as a critical control measure against chemical and physical hazard in large-scale manufacturing. Now, let's dive in for the objective of the case study. Our first objective was hazard identification and assessment to systematically identify and assess the primary chemical and physical hazard associated with all three production processes: nitrogen, phosphorus, and potassium. Our second objective was to define the corrective action and solution. This involves suggesting suitable corrective action, primarily focusing on the process control and instrumentation to either reduce the risk or eliminate the identified hazard in the fertilizing manufacturing plant. We've been talking nonstop about the fertilizer manufacturing, but what is really the fertilizer manufacturing? Fertilizer manufacturing is the industrial process of producing chemical fertilizer that supply essential nutrients to plant. It involves converting natural raw materials such as natural gas, air, phosphate rock, potash, and sulfur into usable nutrient products like nitrogen, phosphorus, and potassium fertilizer. These fertilizers are then used in agriculture to improve soil fertility, increase crop yields, and support global food production. So, why is fertilizer manufacturing important to us? First, it ensures global food security. Second, it increases crop yield and productivity. And it also supports soil fertility and soil health. And critically, it contributes to economic growth by stabilizing agriculture output. However, meeting this global demand requires managing significant technical and environmental risks. The operation of this large-scale plant contributes to several environmental challenges, including air pollution, water pollution, soil degradation, and solid waste generation. Furthermore, the energy-intensive nature of process like harbor wash contribute heavily on the energy consumption.
For this case study, hazard identification was carried out across major fertilizer production processes. The hazards were classified into five main categories: that is, chemical, physical, biological, ergonomic, and psychological hazards. The highest risks were identified in ammonia synthesis, acid handling processes, and downstream activities such as granulation and bagging. Chemical hazards are the most significant risk in fertilizer manufacturing. Workers may be exposed to ammonia gas, corrosive acids such as sulfuric and phosphoric acid, and harmful dust particles. These chemicals can cause severe skin burns, eye injuries, and respiratory problems if accidental exposure occur. Physical hazard mainly came from high temperature and high pressure operations, especially in ammonia synthesis and drying processes. Noise from heavy machinery can lead to hearing loss, while dust and vibration increase the risk of accidents and long-term health issues. Although less obvious, biological, ergonomic, and psychological hazards are also present. Moist environment can promote mold growth, heavy manual handling can cause musculoskeletal injuries, and continuous high-risk operations may lead to stress, fatigue, and reduced concentration. Risk assessment was conducted using the standard risk matrix. Each hazard was evaluated based on its likelihood of occurrence and the severity of its consequences. The risk score is calculated by multiplying likelihood and severity. Based on the risk matrix, ammonia gas leakage shows the highest risk level due to its high likelihood and catastrophic consequences. Most other hazards fall under medium risk, indicating that they require plant controls measure. Equipment vibration was classified as low risk but still requires monitoring. In summary, ammonia gas leakage represents the most critical hazard in fertilizer production. Most identified hazards fall under the medium risk category, meaning they require proper planning and control. Low-risk hazards should still be monitored to prevent future escalation.
Next, we are moving to the countermeasure. We choose two countermeasures from the hierarchy control, which is engineering controls and administrative control. For the engineer control, we can install local exhaustion ventilation (LEV) at the mixing, crushing, and packaging area to control dust and fume. Next, we can enclose noisy machines such as shift shaker machine with soundproof cover to reduce sound transmission. Next is we can install machine guards to prevent contact with the moving parts. We also can use automatic bagging system to reduce workers' exposure to chemical. And lastly, we can provide spill mesh containment tray and drawing system for the chemical leak. Second is administrative control. We can develop standard operating procedure, which is SOP, for chemical handling and machine operation. We can also conduct regular safety training on chemical hazard, noise exposure, and emergency response. Other than that, we can limit exposure time in noisy area through the job rotation. And we can display warning signs such as hearing protection required and chemical hazard area. So other than that is we can schedule routine maintenance to prevent machine failure and excessive noise. Now we are moving to the recommendation. For the recommendation, we have a few recommendations to suggest for this fertilizer, which is the company should continuously improve safety management system and the risk assessment. Next is a regular safety training and refresher courses should be conducted before all workers, and the employers should ensure all machinery is well maintained and complied with a safety standard. Other than that is monitoring of noise levels, air quality and chemical exposure should be carried out regularly. And lastly, workers should be encouraged to report hazard and unsafe condition immediately. And now we are moving to the last part, which is conclusion for this presentation. In the conclusion, the fertilizer manufacturing industry involves various hazards such as chemical exposure, noise, dust, and agronomic risk. Without proper countermeasure, this hazard can negatively affect worker health and safety and environment. By applying the hierarchy of control, risk can be effectively minimized. A combination of engineering control and administrative control can essential to ensure a safety and health working environment.